Hello, welcome back to the Geography 300 video series for geographical data analysis at WVU. We are in the middle of looking at some different spatial pitfalls. We've seen modifiable aerial unit problem, we've seen the ecological fallacy. Now we are looking at how one of the more broader cautions, our data is not representative, can apply in a spatial context. And I'm putting down here that this can be a particular concern with cluster sampling, cluster spatial sampling, where we want to make sure that our data, whether it's clustered or even just random spatial sampling, or systematic for that matter, but especially clustered, we can easily miss things if we're focusing in on certain small clusters. And what we want to make sure is that, at least collectively, not necessarily individually, but collectively, we have a good representation of the entire study area. Now, a couple examples of this would be, we can take, again, the idea from political polling. If I want to understand and do even say a cluster sample with focus groups, say, of how many people support one party or the other. If I base my sample within West Virginia, but I'm trying to understand the national trends, that's not going to work too well. The spatial sample of West Virginia is far more Republican than the country as a whole. If I pick a swing state, if I pick, say, Georgia, on the other hand, that would be a different story. Then, at least based upon the most recent 2020 presidential election, it may well represent the country as a whole not too bad. So, we want to make sure our spatial nature of our sample can represent the full area. This can then kind of tie into a second problem, another problem that can be particularly bad if we don't have a good spatial sample, but it can show up even if we do have a representative sample. Is something called equifinality. So if I look at a spatial pattern, and I want to understand what could have caused that, well, we can look at, say, a pattern of disease cases. And we'll say in part of West Virginia. And you go and you say, well, okay, here's a river. The red dots are where there's the cases. That looks pretty bad. So you might say, okay, there's something in the water. But if I have a sample and a data set that doesn't account for other potential issues, other potential causes, I could miss things. in West Virginia at least, a lot of infrastructure tends to follow the rivers because that's where it's easiest to build. So there could be a railroad parallel to the river. And okay, at that point, maybe it's not water pollution. Maybe instead we have dust coming off of coal trains. So we need to investigate, okay, maybe it's the coal dust. There could be a highway. Okay, if it's a highway, then maybe we need to be looking at the exhaust from diesel fumes of the trucks on the highway as a potential source of whatever is causing this. So now we have the river, we have the railroad, we have the highway. I don't necessarily have space to easily draw it. It could be high tension power lines, but again, follow the river valley. And this serves as a nice tie-in to the next and final video on the pitfall problems. It could simply be there's more people there. People are settling in, again, along the river valleys. That's where the cities tend to be, the towns. And so you find more cases there because there's more people. And it has nothing to do with the river, the railroad, the highway, or the power lines. All 5 of those processes, the river, the highway, the power lines, the railroad, and population density, could all give a similar pattern of where are these cases. And so we cannot distinguish between them. And therefore, there's more than one way to get this final pattern, could have more than one cause to give an equal pattern, equifinality. This relates then back to the sampling and representative. If we make sure we have a good spatially representative sample, we might be able to rule out some of these issues. That we might find, okay, if I go beyond here and the highway breaks off and it follows the river and the power line and the railroad, then I can rule out the highway if the dots continue. If I look at areas along a river and areas not along a river, I might be able to reinforce or rule out that hypothesis. So if we can get our sample as representative as possible to match as many possible processes as we can never get rid of it, but we can perhaps mitigate this issue of equifinality. So, bottom line, if your sample is spatially representative, you can have as much confidence as possible in your results. So, that is that. Again, if you have questions or comments or concerns, please email, please reach out through the Zoom, and I will see you at the next video. Have a good one.